everyone. Welcome to this session. It is so good to see you all again. And it is an honor for me to introduce our speaker today, Professor Emilio Gil. Emilio is a full professor of agricultural mechanization at the Polytechnic University of Catalonia. He has made significant contributions to precision agriculture and sustainable mechanization. He has also led numerous research projects on efficient spraying, collaborating with both academic institutions and the agricultural industry across Europe, and among these, he is a friend. So please welcome Professor Emilio.
Yeah, thank you, Inara. That's the main reason for this extensive and beautiful introduction, because Inara is my friend. Just everything, because I'm getting older and older. I have for close to 40 years at the university. In fact, I had the opportunity to go deep in most of the aspects Inara already mentioned. Again, thanks for the invitations to be here. I will try to give you a quick overview of what we are doing from the both perspectives. One is from the technical and research point of view, and the other, also important, from the regulatory point of view. As you can see in my background in the window, I'm not in Barcelona, I'm in Berlin, where we are having right now, this week, the ISO Standards Committee focused in these aspects. I will explain you later. So regulation, as in the title, is running is lower than technology, and we need to do something. So let me try to share my screen. You see it? Can you see the presentation?
Yeah, we can see the presentation.
Okay, thank you. So just interrupt me if you have some questions or whatever, or if you prefer, we can leave it to the end the questions. This is the title: Precise Spray Application versus Regulatory. As I mentioned, new technology grows faster than legislation. This is the layout of my speech. Why precise sprayer? Some words about the state of the art of new technology, what is happening with the legal framework of PPP, plant protection products, and the gap between technology and legislation. And I will finish with the training as a key point for the success of the whole process. Why we call precise application? This presentation is plenty of videos without sounds, no problem, but you can see here in the screen two already available sprayers for herbicide application in horticulture crops. And you can see the huge differences. The one on the left is the conventional one. We made some research last year in the southeast of Spain. They're applying 1,000 liters per hectare. Doesn't matter the canopy structure. And on the right-hand side, you can see a sprayer from Rumex with AI, with identification of the weeds, and it's able to apply just only where the weed is. So absolutely different. So we have a big gap, right? And another example of technology, so artificial intelligence, machine learning, how the machines are able to identify the target, the objective, because when we talk about the crop protection in Europe, we have a huge pressure, legal pressure. We need to reduce the amount of pesticide. So precise spray technology can cut the pesticide use. So having largely demonstrated, right? But then we have the sustainability goals as well here in Europe and all together. So we have technology, and we are able to demonstrate that we can reduce this amount of pesticide. But not only precise application means to invest a fortune in the latest sprayer with the latest technology. Sometimes best management practices, common sense, well-educated farmers, they can achieve similar results altogether. And altogether, this is the latest document. It was published by the European Commission last year, a vision for agriculture and food. It came after the withdrawal of the Farm to Fork strategy. And if you take a look at this document, it's explicitly established different objectives. In every single of the objectives, the terminology about digitalization, about technology, about AI is included in all of them. And this, I would like to to tell you some words about this because last week we presented a survey we already conducted in Europe about the connectivity in Europe, in the rural areas in Europe, and the influence of this connectivity or non-connectivity in the adoption of the precision agriculture. It's a huge gap still because not in all areas we have the same connectivity as we have in Barcelona or here in Berlin. In rural areas, in small villages, farmers, they have not this connectivity. This is important to know. And all these priority areas, attractiveness, competitiveness, future-proofing, and connection, they are all of them linked to precision agriculture, to connectivity, and with digitalization. Some words about the state of the art of these new technologies. Those videos, I made those videos last year in the right-hand side in Montpellier. This is from Berthoud, a conventional sprayer. You can see we are mimic the presence of weeds in the soil, these pink points, and the sprayer is able to spray only over the weeds. So you can imagine a huge amount of savings in pesticide application. In the left-hand side, you have a John Deere sprayer. Cyan Spray is the commercial name. It's plenty of sensors, plenty of camera detecting the weeds, green over brown. It's another concept when we will talk about green over green. But in this case, again, in both cases, all of them are already available. But we need, from the regulatory point of view, we need some tools to evaluate the capability of those sprayers. It's not enough just listening to the manufacturer saying, so this sprayer is the best in the world. We need to check it in an objective way. And that's the reason why we are here. I'm here this week in Berlin. We are developing new inspections standards. So we need to officially inspect the standards, the sprayers. If the manufacturer says that this sprayer can save 95%, we need to have these protocols. We are already working on that. So can you hear the noise? Sorry. I made these videos in this case. Sorry, I want to take the volume. I do these two videos in a demo, field demo we organized it in Belgium last year. This sprayer is based in artificial intelligence, and we are making a demo how the standard is processing, how the standard is developed to evaluate the efficacy, the accuracy of this sprayer with this and the QR codes or Aruco codes to evaluate the precision of the system. This is an eco-robotics sprayer. This is one of the examples of the new machines already available in the market. The picture you can see here in the left-hand side, where these tennis balls with this white purpose like a cross is the system we are using to quantify the accuracy of the sprayer, because the tennis ball mimics the weeds. And we are using these collectors to quantify the number of droplets in the surroundings of the weeds and outside of the standard, one of the preliminary steps of the standard we are developing. So something for the researchers that they could evaluate this sprayer, we need an international tool, right? This is another video about this eco-robotics sprayer I already sent to you, showed to you in the previous video. For you to know, in 6 meters width, boom width, the sprayer is provided with 160 nozzles every 4 centimeters. In the normal sprayers, it's every 50 centimeters for non-expertise. You see how it's wetting the soil depending on the weed position, and in the video here in the left-hand side, you can see how is the machine learning, and you see this how the system is working. Objective results are providing 95% pesticide reduction. You can ask me about the price of this sprayer. Of course, it's more than 300,000 euros, but it's just a combination, no? It's an economical evaluation. But from the technological point of view, it's a really, really interesting devices. already in the market. I know there is someone already in use in Navarra, also in Murcia, in Almería, and it's a step by step. You remember the first videos I showed you in the beginning, in my first slide, where they apply 1,000 liters per acre. This is another interesting device I would like to show you. This is a Dutch manufacturer, call it H2L, who developed a robot for precise spray application, specifically in tulips in Netherlands. So this system is, for me, it looks like a 3D printer. It's just a nozzle, just in the opposite of the previous one with 160 nozzles. We have just one nozzle. The system detects the infected tulip, and the nozzle is placed over the infected tulip and place 1 or 2 droplets. So high tech, already available. The manufacturers show me some data. There are already 80 sprayers like this working in Netherlands in tulip. It's an autonomous robot, 24 hours autonomy. You can see that. And I took a picture with this robot. Is like, bigger than me, so it's not a small one. It's a big robot, right? Up to now, we have been talking about field crops and horticulture crops, but the most difficult part is when we talk about 3D crops, right? Fruits and trees. Let me give you some overviews about how is going the technology and the developments in terms of precision agriculture. In this case, we coordinated one of the work packages of this European project called Optima, where we developed this, let's say, a smart sprayer. There is not a single smart sprayer in the world. You are smart. The sprayers are stupid. The smart are just reading 1 or 0, nothing else. But everybody is talking about the smart sprayer. So we included in this sprayer 6 ultrasonic sensors. We developed the software, we developed the hardware in order to be able to measure the canopy characteristics and to quantify the amount of pesticides accordingly, with very, very successful results, as you will see there. Because the concept is, as the canopy is not uniform, we are able to measure the modification or the variation of the canopy width, and by the way, the canopy density, and we are able to modify the nozzle flow rate accordingly to this. As a result, this is another development, results will come later on, within the same project. In this case, with our colleagues from Wageningen University, we have been working in the development of this EDS, early detection system. It's a camera able to identify symptoms of the different or specific diseases. In our case, we were working in apple scab in apples, and you can see in the left-hand side of the screen a map of the disease processes, right? So my question is, if the disease is only present there in that part of the parcel, why do we need to apply in the whole parcel? That's the concept of this early detection system that is, by the way, the dream of every farmer in the world. The problem is that it's not so simple to develop, but we have already first result, right? Another level, as the national level, we have been coordinators of this research project, working in olive trees and in grapes, trying to characterize the canopy, to apply this, what we call variable rate application offline. It's another concept than the previous one. In the previous one, we used sensors, we measure, and in the real time, we calculated, or the sprayer calculated and applied. In this case, what we are doing is producing prescription maps based on canopy maps, and then we apply accordingly. The first year, we started with the drones, and then we moved to satellites because drones has complexity. We have advantages and disadvantages and so on. And now we are working in this project, the third year, trying to automate this process, because what is the difficulty of farmers for the adoption? It's quite difficult to download satellite imagery. It's quite difficult to convert NDVI indexes into the prescription maps, blah, 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 blah. So we need to automate the process, and this is what we're doing. And this aspect is linked with the recently resolution published by the European Commission about the mandatory reduction of 61% when using Captan, a certain pesticide, very famous in Europe. Just here, to give you an idea, in this 6 hectares or close to, I didn't mean more than 6 hectare parcel of one of our collaborative farmers close to Barcelona, vineyard area. We made this evaluation. We applied following the pesticide information, maintaining the concentration, and we made a fly with drones. We calculated the NDVI, the variations, and we applied in a variable rate methodology, let's say. So the green, the yellow area, the blue area, and the red area, they have different canopy densities. And by the way, we were able to apply different amounts of volume according to the canopy. In total, 28% pesticide reduction with the same accuracy and the same biological efficacy. So technology works properly, and it has been really demonstrated. Few words about drones. All of you hear about drones. Of course, everybody wants to use a drone. The problem with drones is that the technology is amazing. In that video, you can see a demo we organized last November in Porto, in the Duero River Valley, which is a really specific area with a very slopey areas. And in that areas, it is really fantastic. The problem is that we have not yet proper legislation, or in fact, we have 27 different legislations in Europe, which is crazy, right? So that's what I tell you, technological innovation is moving faster than regulation, but sooner or later, there will be disappear this problem. Recently, the European Commission published the Omnibus last December. They want to split aerial application for drones, right? So we have plenty of regulatory changes. Just take a look at those 2 videos. Can we compare this drone application with the airplane application? So we made these trials in the south of Spain in olive trees, and there is, of course, nothing to do. So we need to separate. How is the legal framework on PPP application in Europe? A few words about very quick. I don't want to bore you with this. The famous Farm to Fork strategy, we established it to reduce 50% of pesticide, and the European Parliament decided to withdraw this political. And then if you try to take a look at the roadmap of the legislation in Europe, it's a chaos because we have the Omnibus, we have the Sustainable Use Directive, we have plenty of legislation about drones. What about the standard ISO 16119 for new sprayers? And then what about risk mitigation measurements? Recently was published the compendium of risk mitigation measurements. And now we are talking about the e-label or digital label. So altogether, it's a chaos. And manufacturers, local authorities, and farmers at the end, all of us, we are crazy with this. But we have plenty of legislation we have to follow. Some gaps about legislation and technology. Look at this. Sometimes we don't need to invest a fortune. Right? So this is a paper we published 2 or 3 years ago from one of my PhD students, Lou. Now, this paper was used as a reference for the European Commission. No technology, no nothing, just common sense and try to apply according to the canopy structure. We have been able to reduce by 35% in more than 1,000 hectares of apples with more than 100,000 euros of savings in pesticide application, right? This is just common sense. There is no sense to hear that everybody is using 1,000 liters per hectare since the beginning, since March to August. No sense. If you take a look at a gap table on the pesticide application, I will link this with the UPATH task force in Europe. We are working, linked with the technology. This is the recommendation for a certain product for grapes, a certain concentration, 10 grams per hectoliter. But take a look at this. If I've been able to convince this farmer to invest a huge amount of money into this new technology with the recovery panels, with ultrasonic sensors, with everything, is for low residual volume, low spray volumes. We tested this spray for 100 liters per hectare. If you compare with the 1,000 liters that appear here in the pesticide label, so the label, it's saying to me that I need to increase 7 times the concentration just because I invest a huge amount of money in the new technology. No sense. It's like if you go to the hospital to receive a chemotherapy, fortunately not, but the doctor says to you, so I came last week from Germany, I bought the latest technology, but just in case, let me increase 7 times the concentration of your chemo. You're running out of the hospital immediately. No sense. And this is what's happened in the pesticide level. And from that, it came this Captain Gate. The European Commission contacted to me and said, can we reduce the amount of pesticide? Is technology affecting this? I said, yes. And then appears a huge and complicated, but at the end, it's demonstrated that we can reduce. Because if you take a look at those pictures, left and right-hand side, the same parcel of apple trees, but different scenario, right? So no sense to apply the same amount per hectare as is established in the pesticide level. So what we did is just, we compare the canopy, the objective, and also important, technology. How many of you has a Ferrari? I assume none of you has a Ferrari, right? Me neither. But it's completely different to have a Ferrari than to have a bicycle. So it's completely different to have one type of sprayer than having another one. So we can reduce largely the amount of pesticide that we are losing depending on the technology. Altogether, we have been able to reduce this 60%. So combination of best management practices, new technology, and common sense altogether. And I had a discussion with someone in Europe about this famous 1,000 liters per hectare, and he told me, no, but this is impossible. Nowadays it's written 1,000 liters per hectare in pesticide level. This is, unfortunately, I made the effort to sell it 25 or 20 pesticides in Europe in different zones. Take a look on the middle column, water liters per hectare, 1,000, 2,000, 800, 1,000. No sense. Remember, technology has been able to show you that it's able to measure every single drop. So who decided to put these values? No sense. And that's the reason why I am arriving to the end. That's the reason why 3 years ago we started with this European Precision Application Task Force. It's a working group in Europe where it's represented legislatory bodies, pesticide companies, agricultural machinery manufacturers, academics, researchers, trying to somehow include technology in the pesticide recommendation. Consider the technology, right? This is the topic. If you Google UPAF, immediately will appear. I really recommend you to go there. But the main objective is this. Broadcast sprayers or band spore or patch sprayer, depending on the target, we are reducing the large amount of pesticide. That's for 2D crops. And I'm trying to coordinate this 3D crop, which is much more confusing and difficult. We have plenty of technology, plenty of devices that every one of them can reduce a large amount of pesticide if we go deep in these band applications, patch applications, uniform, variable according to the canopy, single trees, sensors, no sensors, all together is a count. Going to the end, all together, we have plenty of technology, but we need very well-trained farmers, very well-trained professionals if we want to take advantage of this. We have robots in one case, and there's those 2 videos. I made those 2 videos in the southeast of Spain last year. In the top, this guy was applying 1,000 liters per hectare, as I mentioned. In the bottom one, there's a small sprayer we designed it and developed with the possibility just to modify nozzles over the canopy and try to avoid to spray on the ground. As a result, we achieved more than 40% of pesticide saving with the same result at the end. So no technology, just common sense in this case. Or in this case, when we measure, we compare a conventional sprayer with the just oriented sprayer, 1,000 liters per hectare in front of 500 liters per hectare, we have been able to go from 50%, 58% of deposit into the canopy, the rest were somewhere, up to 81%. And the most important, going down from 1,000 to 500 liters per hectare, combining technology with training. This is how we measure the drift, the amount of pesticide exceeding the canopy, and in the 2 years, the red line is the best management practices sprayers to reduce it. And this is the very important drift curve that is used for the regulatory purposes. In the 2 years, we turn it the same. Then everything is linked to training. It's familiar for you, these images, right? It's a cell phone. So what we are working since years is trying to take the attraction of a new generation, all of them using drones, using mobile phones for everything, for everywhere. This is a serious game we developed some years ago with a professional company trying to train the users in the calibration process. Very simple tools, but on the cell phone. Here you have the Dosavinia tool, the one we developed to select the proper amount of pesticide. And in this video, on the left-hand side, you will see a kind of simulator we already developed within a training program in the European Commission, right, concerning the risk mitigation measurements. I was the coordinator on this one. So these very attractive tools trying to give concepts, interesting concepts. And then all together, this is the preliminary innovative training course. As a result of that, you see the sprayer I already mentioned to you before, just trying to spray only here in the row, nothing or close to nothing in the middle. If you compare with this, the conventional one is 1,000 liters per hectare, everywhere, applying everywhere. And here apply only, let's say, 50%. When we compare foliar deposits and ground deposits, results are really spectacular. 84% over the canopy, only 16% losses, just in the opposite here. Trying to give light on this, last 2 slides, Ainara, is this European project. I really recommend you to at least go through the website, and you can subscribe to the newsletter or whatever. I have the honor to coordinate this European project, 16 members. We are developing a new tools, electronic tools to be used in the devices. But the most important, we are developing training materials to update the mandatory training courses for pesticide application license, because the contents of these training courses are really far away from the situation of the new technologies and the precision agriculture in this case. That will be how it will look. 30 seconds video, and that's all. Yeah, what the video is showing right now is the simulator we are working on right now. So it's for sure you are familiar with some simulators. So trying to pilot F5 or whatever Ferrari. This is the same, but they're trying to mimic the situation of a farmer that receives a phone call that he or she needs to make a spray application because there is a risk of mildew or oidium or whatever, and he or she needs to take decisions in front of the sprayer, in front of the PPPs, in front of the crops. This is how it looks, the simulator. Hopefully by the end of this year, we will be able to launch it. We are in the middle of this European project, and of course, we will be up to service if you are considering. Take home messages, because half an hour is more or less half an hour, right? New technologies are already here. Artificial intelligence, machine learning, advanced sensing already are transforming everything, but specifically spray application process, right? I also mentioned technology has outpaced regulation. We need a clear regulation. Why farmers cannot use drones for spray application? What's happening in France 3 months ago? The Farmers Association, they asked the Ministry of Agriculture to have the green light to use the drones, because after a lot of rainy session, all the parcels were wet and it was impossible to get in the parcels. So drones were the only solution. We need legislation. User competences is critical enabler training, and certification are essential, right? So it's clearly we need this training. Precision application can significantly reduce the pesticide use, but this pesticide use reduction must be included in the GAP table and the pesticide label for the farmers. If not, it's for nothing. I'm not going to invest 300,000 euros just to apply the same amount of pesticide. Altogether, sustainability is included in this, and if we are able to reduce 50% pesticide, we can reduce by 50% at least the risk of contamination. We have plenty of data, but we need more data. So the regulatory bodies are asking us to provide data about the use of drones, for example, how to use this drone, why this drone, why not this another one. Sorry to speak so fast and so quick. Again, a great opportunity for me to contact for the first time for this interesting project, Erasmus project. It's a pleasure. You have here my address. Whatever question you consider, I'm here to answer your questions. Thank you.